Hello and welcome to A Piece of String, the show that brings together comedians and scientific minds to ask and maybe answer the biggest of all questions ever. I'm Matthew Shrimman, I'm a chemist and some might say a biophysicist. And with me today are Fran Grimes, a biochemist.
Hello.
Sophie Ward, a biomedic and a neuroscience enthusiast.
Hello.
And James Wells, an engineer.
Hello there.
Three of us, and three of us only, will ask a question to which one of us secretly knows the answer. Points will be allocated on a tyrant arbitrary basis by our producer, Sam Lee. And the winner will get this really good prize. This is, how many sparklers are in here? Pack of 5 long, standard fireworks sparklers.
Yes.
I'm just enjoying James filtering all the filth out of his iPhone charging cable as I'm beginning the show in my peripheral vision.
I can see demons in there.
He's so satisfied.
That's your iPhone
The
cover.
careless flicking of it over your shoulder, which is the worst.
Ooh, that iPhone port's going to be clean. Sophie, you got a question for us, mate?
Yeah, I do. I want to know how much plastic is in my body right now.
Well, by in, do you mean, what do you mean?
So if you got my body and you blended it up, how much would be plastic? What proportion of me is plastic right now?
Okay. I would say...
Clue, I'm wearing contact lenses, by the way.
Okay.
So,
Good. Do you have any nylon items of clothing?
but it's in my body.
Oh, in your
Like
body.
in
Okay,
me.
good. Yeah.
Joint replacements?
Could be a wedgie or something.
No, not yet. I'm sans joint replacements at the moment.
Okay.
This stage of my life. I'm not wearing my retainers either. So at night time, I've got a bit more plastic in my body in the form of a retainer.
Right, yeah.
I mean, I feel a cop-out answer is that you're entirely almost 100% potentially plastic. Because if you died as you are right now and you were somehow made into a fossil fuel in the future, fossil fuels then make plastic. You're just plastic, mate. You're pre-plastic.
I'm not even
Plastic
fully
waiting to be.
I'm not even potential plastic.
Yeah.
Okay.
Yeah, you've heard about that guy who eats like airplanes, right?
No, I've not heard
Yes.
about that guy.
You know?
No.
Oh, there's a young man, and by young man I mean quite old now, isn't he?
I don't know much about him other than this is something that someone
He's
does.
a French guy who ate like a whole prop plane,
Oh, really?
like a little one. Yeah, bit by bit, got it all down his system and out the other side.
Can we just take a pause? A little plane doesn't make that any less of an
I
impressive
know,
feat. Like,
yeah.
I don't care if it's like a tiny one-person glider or
Can
whether
he-
it's a Boeing.
Can he now fly? Why was he doing this? Why was he?
Because, as you well know, James, when you eat objects,
Well, you are what you eat,
become-
right?
you are what you eat.
In his stand-up set, he'd be like, "So, how about that airplane food?" And it would be the actual airplane. So why did he do that? Just because he had no life? Or
He did have a life, clearly. He was an airplane eater. He actually ate a lot of metal objects, but that was metal. So he had a lot of metal inside him at a time. The reason why I asked, like, what do you mean by inside you? Is because obviously, we're like this big donut, aren't we? So like inside your digestive system, does that count as inside you?
Yeah.
Oh yeah, because it's like technically our like mouth and like our intestines are on the outside because it's like one long hole.
Yeah, it's just a hole that goes all the way through you, right?
What? Is chewing gum like slightly plasticky?
I
swear that's meant to stay around for how long was it? 7 years,
I feel like when I'm
in your system.
I
I don't know the answer to that. I thought it was-
Is.
I thought it was
presume
rubber.
it actually just comes straight out of you, but I don't know. So split what cumulatively over your life, or like weighed up how much plastic is in you, or like when you die.
Yeah, I guess in the average day, how much
The average
plastic
day.
is in me? Because there's like microplastics in the ocean, isn't there? So if I drink water, am I getting little bits of plastic in me if I eat certain food?
On what scale does that cause death in marine life at the minute? So like obviously it's this huge problem where we're getting accumulation of these plastics within things that are in the sea because of the massive, massive amount of waste there. Do we know, does anyone have anything about like how toxic that is? I'm thinking if it was really toxic, if we had like similar amounts in our bodies, you'd think if there are toxic effects for fish, there'd be toxic effects for us.
I mean, it's basically, it's not that the plastic itself is specifically toxic such. It's just that like loads of the pollutants in the ocean are like hydrophobic, as in they don't really like water. So if you have like tiny bits of plastic in them, then they'll be attracted to them like magnets because they're like, oh, I can stick to this instead of sticking to the water. So all the old like first like DDT, for example, which is a really harmful like agricultural chemical, all that kind of stuff just like sticks to the plastics. And then when the fish and the filter feeders inevitably eat them, they pass through their system and then they absorb all of those chemicals. So that's why all the chemicals like concentrate up to the top of the system, and that's one of the big reasons why the microplastic is such a problem. But then also like the plastic in the ocean is a problem because like birds, you've all seen the things, right, where seabirds will like pick them up and feed them to their young, and then the young will die because their stomachs are literally full of plastic. So the plastic is really inert. Like it really doesn't react very much, and it's not. As from what we think at the moment, like when it's in bigger bits, it's not necessarily that harmful directly, but its indirect harmful things are all really, really bad, and that's why it's so damaging for the fish because of things I just said. But then there's also now loads of evidence that the plastic particles are getting so small that they're being like carried by the air, and then we're like breathing them in, and then they're kind of crossing into the blood. So
there is plastic in me from breathing it in.
Oh yeah.
Is there a lot? Can someone tell me how much there is?
So yeah, in terms of how much plastic there is actually in your body, depends on what kind of lifestyle you have. Depends on where you live. But the idea is that everybody has some plastic in them now. If you like look at plastic distributed around the world, it's a friend of mine, Joe Ruxton, who runs like the Plastic Oceans Foundation. She made the film and was one of the main people who got it into like the end of Blue Planet as well, all this plastic stuff. She had this expedition where is it an expedition or a voyage when you're going out to sea?
Voyage.
It has to be a voyage, doesn't
course,
it?
Yeah.
Anyway, they had a voyage where they were taking like a robot to the bottom of the ocean in a place that they knew was supposed to have quite a bit of plastic in it. But there were all these things that went wrong. And so instead of having multiple days to get there, lower the robot, do the tests and so on, they literally had like half a day. And so all they could do was just go to some random spot in the ocean that they didn't think would even be that bad, lower the robot to the bottom. And even there at the bottom, they found plastic absolutely everywhere. At the moment, we think that like 80% or so of all the ocean plastic is sinking. So people think, oh, it's floating on the top and therefore we can clean it up. We can't. Like we literally can't. We're never going to be able to clean it up. And that's why we just have to stop using it. But yeah, plastic in your body, so it's working its way up the food chain. So like loads of the fish are eating plastic, and then traces of it are getting into their bodies. And yeah, whilst it takes longer to get to us, we are now at the point where, as I said, there's like plastic in there, and we're literally kind of breathing it in, like tiny pieces of it that are not biodegrading. So I can't answer your question exactly because the research on this is still being done. But the point is, there's a lot of plastic, and everyone's got it in them. So we've got to stop using it as soon as we can, as much as possible.
And the solution isn't for me to eat it then?
Solution is not for you to eat it. Something really, really important about plastic as well is that recycling is not good. Like everyone thinks, oh, we can recycle it and then it'll be fine. But you can't, because like every time you recycle plastic, you actually downcycle it. So it then ends up as a less useful form of plastic and so on until eventually it has to be thrown away anyway. So it's not like a continuous loop.
Really?
Yeah, you can't. Yeah, recycling plastic is not the answer at all. Like it's not a long-term solution.
Cutting down uses like this.
Just have to stop using it. Yeah.
I was in Whole Foods and there was like this woman giving out like this like juice drink thing. And she was like giving out a sample in these little plastic cups. And as she was talking, she was like, oh, and we use all like the bad, like not the bad fruit, but like the ugly fruit to make the juice. So, like nothing goes to waste. And as she said, nothing goes to waste, me and my friend like dropped our plastic cups into a bin full of other plastic cups. As she was there like, this drink is great because nothing goes to waste. And then we just dropped. Does anyone else get the ridiculousness of the situation? My mate, we both afterwards were like, that was ridiculous. Like,
I think it's time for an Alanis Morissette ironic follow-up, which is all about people's lip service to the environment versus their lifestyle, which I am wholeheartedly guilty of.
So what can we do about it, Matt? Try and cut the use down.
Well, yeah, I mean, there's a lot of work being done on potential replacements, like plastic made of seaweed and stuff like that, but it's not scalable. Like really, we are just so far from that being a good solution that it's just not something that we can sit back and think, oh, the scientists are figuring it out, because we're just so far away. I mean, the best stuff that we have is like polylactic acid, which is at least slowly biodegradable, but it can only be used for a few things. And even then, like it still biodegrades really slowly. So it'll still get into the ocean. It'll still have all the pollutants stick to it. It'll still kill loads of sea animals that might get tangled in it. Or
Is that like a plastic replacement then? That?
polylactic acid is using of quite a few things. You'll see it in a few things, but it still has all these dangers associated with it because even though it's biodegradable, it's not really that biodegradable. Like you go to, I don't know, I was in West Africa last year and there was this town, in this town called Cotonou, and their waste disposal system is just not very developed. And it used to be fine because the waste would just go in these piles and people would kind of sort the piles and those piles would just biodegrade and go down. And now the piles just get bigger and bigger and bigger because the plastic just never disappears. But yeah, polylactic acid is kind of, it's better than normal plastic, but it's still really bad. And then compostable plastics are okay sometimes, but they're a bit misleading because you can't just put them in normal compost because they won't degrade. You have to put them in like an industrial composter that gets really, really, really hot. And there are quite a few of those in the UK now, but like in the whole of Asia, there's only like, I think there's like less than 10 in the whole continent. And so it's definitely not a solution over there.
One of the things is looking for alternatives or places we can cut use of plastics down. And I think food packaging, am I right, is one of the biggest kind of
like
feeders into this like plastic apocalypse, if you want to call it that, which I do. So I did. Do you like, I suppose, what are the main messages to kind of people who want to be more responsible about their own plastic use regarding things like food packaging?
Well, I mean, yeah, any like packaging in general is one of the biggest parts of the problem. So
just use like cardboard.
Yeah,
there's so many of the materials, isn't it? Like we've just got so used to the plastic.
I think the supermarkets will gradually take note as people just refuse to buy the things in plastic. So in general,
if people do,
but I think people are trying to, and I think it is slowly happening. I think it's hard, but like gradually it feels like it's moving in that direction. And the more people like pick up the oranges by themselves and like just bring them to the counter without them being in a plastic bag rather than picking up one of the plastic nets, the more the supermarkets are like, whoa, people aren't buying the plastic nets anymore. And then it becomes like a profitable thing for them to avoid it.
Yeah.
And I know these are like small things, but you just have to like, when you going to the supermarket is one of the best things you can possibly do in terms of like changing the way that you shop there, and like encouraging everyone else to do so as well, because that's where like a huge amount of the problem is coming from.
You just got to ban it, haven't you? Right?
Plastic.
Yeah, if you just ban various types of it, people would literally have to come up with other solutions that work.
Well, like a plastic
And that's just the way to do it, right? You just go, okay, no more plastic bags at all.
Oh, yeah.
So it's good that they've phased in like a charge and stuff, but it's just get rid of them completely.
Like
and then,
a governmental, like a policy level thing.
Yeah.
Like in Kenya, if you're seen with a plastic bag, then you go to jail, don't you? You just can't use single-use plastic in Kenya. It's just totally not allowed.
Yeah.
Really?
And like, you know, we look at ourselves and we're like, oh, you know, we've got this 5p plastic bag charge, that's great, but it's just so small compared to what other places in the world are doing, who are taking a much more sensible outlook on the problem. You're right, yeah.
What about medical research and medicine and scientific research?
Yeah.
Like that must surely be, and I suppose it's that there's a case for saying it's worthwhile because the output from using things like disposable petri dishes and like single-use pipettes and all of that stuff is like huge in terms of driving the rate of scientific discovery.
I mean, there are obviously cases where like plastic is useful. Like it's a really good material. It's an amazing material in terms of being able to help with like transplant surgery and help with like babies born prematurely and like fitting the ventilators and stuff like that. Like there's unbelievably brilliant things that you can do with the material. And plastic is not a material that's going to disappear, but single-use plastic is something we have to,
So yeah, it's all about like changing the way we use it, but still using it and managing it, I guess.
Yeah, in general, just got to stop using it.
Okay.
Fran, you got a question for us, mate?
So I've got a question. Inspired by other questions that we and you have all talked about. We talked quite a lot about the Earth's atmosphere and how it's changed and how from space the Earth's look different. But what about from the Earth's surface? So my question is this. When the Earth's atmosphere had a different composition, did the sky look a different colour?
Oh, I hope so. Don't you just want it to? You know what I mean? Don't you just want the sky to have been different? Isn't that exciting? And sort of like be changing as well.
James,
That would be brilliant.
What do you want the sky to
Any
look
other,
like?
literally any other colour
Sick
that
of
we
blue.
have at the moment. No, we've got black.
We've got black. We've got like,
Famously, we've got black.
Sick of blue sky
Yeah,
thinking.
literally any
James.
other colour, I would be excited about that. Even if it was like a weird, murky, translucent grey, which we do get
Which
quite
we
a
do
lot.
get
it
We do
quite a
get, but
lot.
not entirely. Like it's usually clouds and stuff, so you can tell that it's just a cloud.
We never get green.
Green. You know what? You do get a bit of green sometimes.
green flash.
Yeah, green flash.
What's green flash?
Green flash is when the old James.
Go on. We'll do it in. We'll do a
I'm doing
couple of words
such a
each.
round at this point.
So
I'm like, don't believe.
Just
this
when
thing.
the sun's about to
Disappear below the
horizon, you get this strange
little flash of
green.
green.
yeah, green.
Yeah, when you're when the sun goes below the horizon, like the light coming from the sun, when it gets to the earth, some of it slows down. Well, it doesn't slow down, but it kind of takes a longer path to get to you. So the red light comes directly at your eyes, and the green light kind of gets bounced around a little bit, and so it kind of wobbles towards you. And the blue light kind of bounces around all over the place, comes at you from every direction, and that's why it looks like the sky is blue. But when the sun goes down below the horizon, then all of the red light that's coming towards you suddenly stops, but there's still a little bit of green light that's taken a slightly longer route that hasn't quite got to you yet. So the sun goes down, and then you get this flash of green from the last bit of green catching up, which you couldn't
Amazing.
really see before because the sun was too bright. But as soon as the sun disappears, you can suddenly see it for that moment.
To be
I don't
fair,
think I've
I've
ever
never
seen
actually
it.
seen
I've
it.
never seen
Yeah,
it.
I was
I've
gonna
looked
say,
out
like-
for it, and I've been like, nah.
Which is a green? Is it like a green flash, like boom, like immediate?
Yeah, it's really quick.
Oh,
Yeah, and like
okay.
the best way to
Blink and
get
you
it
miss
is to
it.
like get a fast motion camera.
Oh, I was thinking like
Oh, little
matchsticks on the
sticks,
eyes.
yeah.
thinking.
Don't blink. Don't blink.
Like a scene from Clockwork Orange. Beethoven in the background.
You never not blinked for a whole day, Fran?
Yeah,
We have.
when I've slept for a whole day.
Ooh.
Oh.
Right back at
Common
you. Isn't that
occurrence.
one big
Absolutely
blink thing?
typical scenes for Fran.
Yeah. Oh my god, Fran, that was
Classic.
Slow-mo blink.
sharp. So firstly, what is the composition of the atmosphere now?
Now it's about 79% nitrogen, 20-ish% oxygen, and then the other roughly 1% is things like carbon dioxide and methane.
She's a science
Back in the day.
teacher.
Yeah, this is
It's on the syllabus.
people who are doing AQA spec GCSE will know that this is on the syllabus.
Where
But
did the word
it's-
argon come from?
Jason and the Argonauts.
Yes.
Is that true?
No, it didn't. It came from because that was the one that they discovered when they were cooling.
All the
down
others are
air
gone?
To try and
That's a joke.
I don't know what it was, but they were cooling down. They were
That's a
cooling down
noble
air,
joke.
and that was like the missing 1% because most of that 1% is argon, right? And they were like, "Oh, what's this mystery gas that they found?" And anyway, sorry, James, you got an answer.
But what's the answer? I
Oh,
missed
well,
the answer.
early, if you want to know quickly, just early atmosphere compared to now was, I don't know the percentages, but pie chart wise, the biggest bits of pie were carbon dioxide and I believe ammonia and nitrogen, because it was all a product of the massive planetary scale volcanic activity. So the difference is like they're basically they're completely disparate
Those are the nasty
atmospheres.
poison ones now, aren't they?
They are.
Ooh,
Go on, James.
Right, well, just a quick one. Yeah, I thought, right, my initial thought was that it was all carbon dioxide back in the day. So I thought, right, well, Mars's atmosphere is basically carbon dioxide from memory. So I had a look at it. It's something, so the pressure on Mars, teeny tiny. It's like
Yeah, mate.
less than 0.5% of the pressure, atmospheric pressure that you have on Earth. So that's something to consider. Like you need a lot of atmosphere to change the color. So otherwise you just, like on the moon, for instance, you just look out and see dark sky, basically. You need quite a lot of atmosphere at first. I think Earth would have had that back in the day. But to continue on Mars, I just like this one. Do you know about Olympus Mons on Mars?
Ah, the huge mountain.
A massive mountain, yeah. It's just absolutely bafflingly huge.
Wait, how
It's
big
like
is it?
it's 25 kilometers tall, like
Okay.
from the average level
Wait, how
of
tall
Mars.
is Everest?
That's like 8
No
and
way.
a bit kilometers. And there's a beautiful thing about this. So this mountain couldn't exist on Earth because the gravity would be too much that the material that it's made of on Mars would crush down, which is just a nice sort of idea. So you can't do that. So on the top of that, it's 20 times less atmosphere than on your normal standard bit of Mars. So
Whoa.
it's not
That's
that
like-
comparable is my point. But on there at sunset, the Curiosity rover sort of picked up a picture fairly recently, and you get
Wait, on the
blue-
top of the mountain.
not on the top of the mountain, but elsewhere.
Heavens.
elsewhere. Yeah, literally heavens. And it was at sunset. It was blue. It goes blue at sunset.
Whoa.
And then it's
on
like, so it's like
Mars?
red during the day. And then when it gets to sunset, it goes like this lovely, strange, eerie tint of blue.
Wait, Mars the planet or
That's
the sky
Mars,
in
the
Mars?
planet, the sky in Mars, yeah.
So the sky in Mars is normally red.
So normally, if you were just sat there during the day,
Yeah.
you'd be like, it's slightly orangey red
Oh,
everywhere.
really?
That's because of the fine dust particles
Right,
and,
okay.
and not so much what the gas is. Interestingly. So yeah, so that's Mars. So apparently, actually, the Earth was mainly methane back in the real dark days. It might have turned into carbon dioxide at another point, but when it was methane, people looked to Saturn's moon, Titan, to sort of compare, because Titan is considered like an early Earth in sort of some ways. It's a very similar size. The atmospheric pressure is about 50% more, so it's fairly similar. And the sky is orange all the time.
What, on
there.
Titan?
On Titan, yeah. So
Oh.
they say if the Earth that they predict was mainly methane, sort of a very long time ago, you'd get orange skies.
Oh,
Isn't that a delight?
wow.
Isn't that a delight?
Ridiculous.
That's lovely.
That was so
Ridiculous.
beautiful.
Should be
It's
shut down.
Mental, isn't it? So yeah, there you go. There you go.
Well, when you said about how Mars sometimes has a blue sky, I was like, imagine that, a blue sky in my head. And then I was like, oh wait. I was like, and then I looked
dear.
outside and was like,
Wait a minute.
hang on, I can't pick a second.
And now for the mystery midsection. Just before we started the show, I gave everyone the following question.
The longest word published in the English language is pneumono-ultramicroscopic silicovolcanoconiosis. What is it?
I then asked everyone to write down a fictional but reasonable sounding answer. I'll now read out all of those answers with the real answer mixed in. Everyone will then get a chance to decide on which answer they think is right. Answer number 1. The act of drilling tiny little holes in rocks. Answer number 2. It means someone had too much academic funding. Answer number 3. An occupational lung condition caused by the inhalation of dust, silica, sand and ash. Answer number 4. A lung condition caused by the transfer of microscopic parts of silicon breast implants entering the lungs following a rupture or internal eruption. And answer number 5. A condition of the lungs resulting from exposure to microscopic strands of silica that irritate the lungs in such a way the healing process damages them further.
They're so similar, aren't they?
Oh my days.
Would you like any recaps?
Someone has
Little summaries?
analysed this very well. Okay, so we got active drilling, too much funding, occupational lung condition eruption, lungs, strands of silica.
But what was it about the holes in the rocks? What
Just
does
drilling.
it mean about them?
Just drilling
It's
holes in rocks.
Just
the
an act of
word
drilling
for it.
holes in rocks.
Yeah,
Yeah.
okay.
Oh, we're gonna do some
Get
pneumono
those holes into
ultramicroscopic.
those rocks.
Yeah.
Mm.
Get those. Can you imagine the foreman on the building site being like, "Get the holes in the rocks," but they'd use whatever that word was.
What was the word?
Get on with the
Huh?
job, boys.
before that word was
invented.
This is pneumono ultra macroscopic when they're too big. So they've done the
Yeah,
holes
that
too
is
big.
true.
Mate, they'd have been having a good laugh about that when it went macro, wouldn't they? Mates. Pretty macro coney volcano silico today, boys. Why do I keep saying boys? That is rude.
That is
Although to be
rude.
fair,
There's nothing rude about
there
being
are
a boy.
boys- It was only boys on a building site around my place at the moment. So that's what I'm imagining.
So
I'm imagining those guys. Anyway, we got an answer, Fran?
Me.
Yeah.
I have, yeah. I think it is the breast implants that they rupture internally or erupt internally, hence the volcano part.
Yeah, I think
They're made of
whoever wrote that
silicon
answer made
And the
it
very small
clear.
parts that get into the lungs, which is the pneumo.
Mm.
Wait, what was
That
the
for me
last
has all the
one?
things, and it's got enough Matthew Shubman that it could be false and wrong.
Yeah.
But I like it, so I'll have it.
This one's making me quite anxious. I really don't know.
Was that all a joke? Because you wrote them, so you know what the right answer is.
I know what the right answer is.
That was
poker
yours.
face.
I was confused when you asked me for an answer, so I thought I had to commit to
I think
one.
that's yours. I just want to work out which one's Matt's and then not pick it.
Yeah, massively don't want to fall again. I think it must be edging towards 100%.
Yeah,
it's just
monstrous.
relentless.
It's
I'm
killer.
worried that there are
Can't
two
know
that are
myself
very
better.
similar.
There's 3 that are pretty similar.
Yeah, there's 3 that are similar. The last 3.
You got is it silica fibers? The last one. I reckon it's the. I hate it though because it's going to be Matt's, isn't it? I'm going to go for the sand ash one.
Wait, how is that different? So how are the 3 lung ones different? You got internal
Would you like them again?
eruption.
Yeah.
Not that-
Send them
not-
again.
Yeah,
Inhalation of dust, silica, sand, ash, like general debris in the lungs.
and it's occupational.
And it's
innit?
occupational lung
Okay.
condition. Yeah, the second one is that breast implants have exploded and parts of them are now in your lungs. Also a lung condition, therefore. And the third one is another lung condition, but this is from microscopic strands of silica that irritate the lungs and stop healing process. Don't stop the healing process, but the damage is such that the healing process causes further damage. Pneumono-ultra microscopic silicovolcanoconiosis.
Right.
She said like she'd rehearsed it
I'm going
many
to go
times.
for answer number 5. The strands, the little strands of silica.
What are you going to go for?
laughing, which
What are
means
you
I'm
going to go
just-
for, Matt?
I'm going to go for the breast implants as Fran recommended. I'm going to go with Fran's recommendation.
Okay, what I'm going to say means that one of us is going to have chosen Matt's. I'm going to say the ash, the occupational lung condition with the ash.
It is my delight to say that today Sophie is the winner with the correct answer. Matt fell into my trap.
It was a good trap.
It was a booby trap.
It was a good trap, but it had all the elements in it.
It wasn't really
It did have all.
It did have all the elements. James
sick.
for mine.
And James was close, but
Oh, man.
No,
I feels like a double
nightmare.
victory, the fact that like you chose Matt's as well.
So it's just silicosis.
it's literally it's a synonym for silicosis.
It's just silicosis. Crap! I thought it was something special.
All my days I didn't get tricked and I won. This is the best day ever. Oh, sick.
Nice work. James?
So yeah, I do have a little question. So we see snails move very slowly, but is their perception of time different? Do humans move fast? Too fast for snails to see? And that's from Ellen Croft.
That question before. Just the way you worded it.
Did it show that I'd never read the question before?
Had you never read it?
I'd never read it before.
How dare you, James?
I wish I hadn't read
But
the
I'm
ones
so
that
glad I have
should be
now.
reading today.
This was from Insta.
So yeah, so that's from Ellen Croft. So thank you for the question, Ellen. Appreciate that.
I always wonder, you know how birds move in like twitches? Is it because their brains like put out commands at a certain rate and they can only put them out like bit, 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 bit? Do you know what I mean?
It's definitely true for humans that there's a minimal perception rate, and you can actually do things that are changing quicker than that, and humans can't pick it up,
yeah.
like a change in the picture. So yeah, I reckon, but it's surely is to do with their muscles as well, the way their muscles twitch and fire.
Yeah, I think that active.
I think we're quite good
twitches
because we've got a
probably.
mix, so we can do things like that.
Yeah.
How steep a wall can a slug climb up? Just a vertical wall, right?
Can it go, like hard climbing, backwards incline? Do you know what I'm talking about?
Yeah. when you,
Spider-Man
like-
hang,
Yeah.
Yeah, slugs
I believe
can
is
do
what they
that.
call it.
Spider-Man
How
hang.
many slugs stuck together crawling on top of other slugs could crawl across the ceiling?
Would you call it a crawl?
like a
A slug, that
slug
way.
pyramid.
You'd get to the point where they'd cover the entire distance from the ceiling to the floor, wouldn't they? So you
Every
just
slug
you
was
could have,
stuck to another slug, yeah.
and then you just have the last one back to back, and they'd be
That'd be like a slug pillar that would just move across the room.
Yeah.
It'd be a nice feature, that, wouldn't it? People would come into your house and be like, "Oh yeah, this is a lovely period."
I wouldn't lean on it.
Slugs.
Oh, but imagine if you'd spilled the salt somewhere. Like, imagine you'd have to be
Yeah.
so careful.
Pillars of
Willow
salt,
slug.
pillars of sand, pillars of slugs. The combination. So what the question is, do we move? Can snails and slugs not see us because we move quickly and they move slowly?
Can snails see? Should we start with that?
Yeah, I think so.
Oh,
No, if you
yeah.
poke
Okay,
their
okay,
eyes,
okay,
because
okay.
they go back in. Don't
Oh,
Oh.
Do you used to do that as a kid before you
I was
understood that they might feel pain?
I was going to say this. Are you the
No.
kind of kid that A, pokes snails in the eye,
Correct.
that B, pours salt on snails,
No.
or that C, catches snails, puts a little bit of nail varnish on their shells and then sets them free to see when they see them again?
To see.
Yeah, I'm a
To
C,
see.
C as
Firmly
well.
I
see
never
for me.
even thought that's possible.
Yeah, see how
That's
far
brilliant.
they travel. Put
Oh,
some
I
nail
like that.
varnish
I might do that now.
on
Yeah.
them.
I want to know how
Oh.
fast does it move and how fast do we move on average?
How fast does a snail move?
Yeah. I'm in the mood
I
for
think I
some
actually know
maths.
that
I'm
one.
feeling like I want to know these
I
facts.
feel like
About one snail's worth.
How many
snail,
snails
one
does a
snail a
snail
second.
move?
Weird, I've got that number here. Can I read it? 0.2 of a millimetre per second. Yeah, that
That's
sounds
really
about right.
fast. That
0.2 of a millimetre a second.
0.2 millimeters a
0.2
second.
millimetre per second, yeah.
Times
Or 0.3
60,
actually.
so
Yeah.
2 times 6, so like a centimetre and a bit every minute. Is that it? Actually, that's quite slow.
Yeah, that's really slow.
Turns out it's quite
Yeah, it's really slow.
Does he not know?
What's human walking speed? I want a human walking speed. I want
I've
some.
literally
It's
got
like
all
5
because we
meters a
did this in
second,
a
isn't it?
previous thing.
5 meters a
Human,
second?
I mean, you've got
No, it's
30
really
miles an hour for a bolt
Oh,
at his peak
can
speed.
I get a meters per second?
You can,
It's
12.4.
usually about half and a little bit less.
yeah,
Yeah.
12.4.
Okay.
I was thinking of a nice scene of a snail waking up in the morning, and then and it's just coming out of its shell, and then out of the shell comes the head of like a slug, and out of the same shell, and then the snail is like, oh my god, what did I do last night? Like, how can that even happen? Can a slug fit inside a snail shell with a snail?
Isn't a snail just a slug with a shell?
They are attached to their shell, right? They are physically attached,
Oh,
if you know what I
yeah.
mean,
Oh,
rather than
yeah.
just being in it.
You don't get like hermit.
Hermit
Snails.
I
slugs.
never thought of that.
Yeah.
Yeah, they are attached to the shell, aren't they?
You ever play Banjo-Kazooie?
Yeah.
That old game with the bear, and then the bear had
Yeah.
a backpack with
Oh
a
my God,
bird,
yeah.
and so one of them could walk, and the other one would ride on the top of the other one like a backpack. What would it be like if there was like a conjoined snail twins where they both had the same shell and they could kind of roll over like a buffalo roll, and then one of them could take over from the other one? What would that be like?
It would
I
be
want
just
to know
like
what that would be like.
just like you described it.
Okay,
Matt.
right, moving on. Has
You really
anyone got an
paid me.
answer to this?
Yes.
Can I do a speculative answer first?
Yes.
Go on.
Go on. Challenge
We're
my
gonna just cut it.
authority.
So I was thinking, if we assume that the general perception of speed is equal across all living things, a snail, let's say, is roughly moving. A snail is roughly moving in terms of like orders of magnitudes, which is like powers of 10, 1 times 10 to the negative 4 meters per second. And a human walks at 1 to the power times 10 to the power 1 meters per second. So the difference, like orders of magnitude, is 10 to the power 5 or 10,000 times faster.
Yeah.
All right.
So
Yeah.
humans
100,000 times faster.
So
100
humans
Now,
move 100,000
humans
times
move-
faster than snails.
Absolutely.
Okay.
On purpose.
And then I thought, well, can we see something? Can we see something that moves 100,000 times faster than us? And the land speed record is about 100 times faster than humans' movement. And we could obviously can see that
100,000 times faster.
100,000
Yeah.
times faster. So I think, yes, snails can see us. We are not mysteriously too fast if they can perceive the same difference in frequency as us.
But we didn't know that until
And
the land
now
speed
for the
record was
real
set.
answer.
Yeah, interesting idea there, Fran. It's cute. But no, I'm joking. So it's kind of, I did some research about kind of perception and like how quickly we can analyze sensory information, right? So basically, different animals kind of take in the world around them at a different number of like frames per second. So you can think of it as like, if we look at a light flickering, if that's flickering like 5 times in a second, we can see the difference between, we can be like, oh yeah, it's on. But different animals have different rates that they could still see the flickering at. So if the light to us is flickering like 100 times in a second, it just looks like it's constantly on. Whereas to some other animals, they can still see the individual flickers, right? So essentially, some animals like birds see everything in like very like lots of frames. Like they move very quickly. Then when they're flying, like it's because essentially the world is in slow motion for them because they see all the little frames, all the little details.
So eagles have got like 250 frames a second. Is that right? Something like
I don't think it's quite that high because insects are the highest and they're on like 300.
that? Okay.
So I think it might not be quite that many for eagles, but it's something really high, which is why like, you know, they can react really quickly and they can like dive after prey or whatever. Same with like a fly, like it's really hard to spot a fly because it's basically you're like approaching it essentially in like slow motion and it's like, oh, I can move away at the last minute.
So just to make sure people know what frames per second mean, like a human needs to see at least 24 pictures every single second to be convinced that it's moving, that it's a video, right?
Exactly.
Otherwise they see like a flickering thing. Whereas to convince an eagle that they were watching that they weren't watching pictures one after the other, you'd have to show them 200 pictures a second or something.
Exactly.
Yeah, cool.
Exactly. Yeah, it's like the difference between a slideshow and a movie. So snails have a much slower frame rate. So they essentially see things in like stop motion. So they'll see things like individual pictures because their brains are taking them in like it's like
So they have a low frames per second that you need to convince them something's moving?
in a second.
Yeah.
They see very few frames because their brains are analysing it slowly.
Yeah.
They see like 14 frames within a second.
How on earth do we know that?
So they study it using like flickering lights essentially.
Yeah.
So it's known as the frame rate is known as the flicker fusion frequency, the FFF. And they analyse it somehow, I don't know how they do in snails, but they judge it with different animals by showing them a light flickering, I guess.
Yeah.
And like at what point is it judged that they're like recognising separate flashes and at what point is it like, oh, that's all in
Just
one go.
continuously on.
Yeah.
Whoa. Okay, so you only need to show them 15 pictures a second to make them convinced that it's like
That something's-
continuously on.
Exactly.
Yeah.
So I think when it comes to snails seeing us move, it's not that we would be moving too fast. They would just be seeing us in a very different way. So they would see us move, but we would look more like stop motion-y because they're taking in fewer images in a second. So we would look less smooth. Does that make sense?
Do you think we would though? Surely I think it's the other way around where like to an eagle, our videos would look really stop motion-y because they have a really high perception. They perceive it really, really fast. So they can see that it's separate frames. Whereas if a snail is only like picking up 15 frames a second, I would think that's the other way around where like they see everything as really smooth.
So the way that I thought about it was like, because an eagle like sees every single movement to an eagle is like broken down into lots of little movements because it's taking so much in, which is why like it's slow motion. So it's like, whereas a snail, it would be
more like fast motion.
My hand is here, then my hand is here, then my hand is here because it's taking in like less.
And I guess we can't know if a snail's brain then like smooths that out or not, can we?
Yeah, exactly. Because I'm not a snail, Matt. I've tried, but
okay. I reckon though, if a snail can only see 14 frames a second, then if you move fast enough, I reckon they won't be able to see you.
Yeah.
If you only
Exactly
exist in their field of vision for like a 1/200th of a second, what are the chances that that is going to be at the same time as one of those 14 like times that it's like perceiving the world in front of it?
So you've got to move very quickly then.
You know how like when a propeller moves so quick that it looks like it's not there?
Yeah.
Because the blade is thin and like every moment that you're perceiving, like you don't actually pick it up because you only get 24 pictures a second and none of those pictures happen to have the blade in. Like it must be similar for a snail. If you're moving really, really fast, I reckon they can't see you.
But for fun fact, the animal with the lowest frame rate is the deep sea creature Borolana tricarinata, which has such a low frame rate that it probably can't track something moving. So you're like, oh, it's there, now it's there, now it's there. It wouldn't have like a smooth movement.
That's so cool that we know this stuff about these
I know,
animals.
it's mad.
Sorry, I'll stop.
And all that discovery was led by Ellen Croft's questions. So thanks, Ellen.
That's great.
It was a
Great
interesting
question, Ellen.
It was a great question. Yeah, snails can't see you, so don't be mean because they'll remember.
And we have arrived at the end. Points have been allocated by our producer, Sam Lee, according to a system that none of us were aware of until now. Sam, what's the old verdict there?
Well, contrary to the cooling, wintry weather that's been settling in of late, there's an almost summer fate atmosphere in the Piece of String studio today, as I've assigned each of the panellists a Guess My Weight in Plastic competition, which they've all very gainfully attempted. And I can reveal the scores as follows, based on what you all guessed. Based on the amount of plastic you all guessed was in my body. James, 1 grain, the earliest known unit of mass, equal to 0.0647 grams. Wrong. Matt, 1 pennyweight or 1.55 grams. Wrong. Sophie, 1 dram or 1.77 grams. Close but no cigar. Well, not close at all, in fact, because Fran, you're this week's winner. Guessing as you did 1 biblical Hebrew talent, which is about 34.2 kilograms.
Yes.
Quite a lot of plastic, but certainly sufficient to mould this model of myself, which I have, which you're welcome to keep, in addition to your prize this week.
Thanks, Sam.
Thanks. For now, thanks to Sophie Ward,
Cheers.
Fran Grimes,
Thanks.
James Wells,
Thank you very much.
Matthew Shribman, that's me, our producer, Sam Lee, and to Unbound for their generosity in hosting and supporting us. You can follow us on social media by searching A Piece of String or String Podcast.
Or Soaps Notes if you want to follow me on social media.
And if you'd like to learn about many and various scientific curiosities from a man in a bath or otherwise located, you can follow me on social media by searching Science in the Bath or Matthew Shribman.
And if you've got a quirky question of your own that you'd like a scientific answer for and us to have a bit of banter about, then please reach out to us on any of our social media channels.
Thanks for listening. Please rate and review us on Spotify, iTunes, etc. It really makes a big difference in spreading the word. We'll be back again in a fortnight, and as usual, let's never speak of any of this ever again.